This is Algebra 2, Lesson 8.4, Dividing Rational Expressions. We're going to go through the steps and then we'll practice some problems. So first off, when you're dividing rational expressions, you need to multiply by the reciprocal of the second fraction. Dividing rational expressions is the same thing as dividing fractions. You're just going to be doing it with binomials and trinomials. Once you've multiplied by the reciprocal, you need to factor. Factor everything that you can. Once it's all factored, you need to look for restrictions. The difference on division problems is that when you come up with restrictions, you need to include all parts that were ever denominators. So that means in the very original problem, you had the denominator that when you did the reciprocal became the numerator. So I'll clarify that as we go through our first example. And after you've done your restrictions, you can simplify. Remember, binomials have to be exactly the same in order to cancel. Our first example, when you look at this, I've got two denominators already given to me, x cubed plus x and 3x squared plus 3. When I go to state my restrictions, I have to include this 3x squared plus 3. This portion also cannot be a 0. It is originally a denominator. All right, I'm not going to worry about it right now, but keep that in mind as we work through the problem. So first off, I'm going to multiply by the reciprocal. The reciprocal means that I flipped my fraction. What was in the denominator, I've moved to the top, 3x squared plus 3. And what was on top, I've moved to the bottom, x squared plus x minus 2. Step 1. Step 2, I need to factor everything that I can. So working here with this numerator, it's a trinomial. What multiplies to give me 1 and adds to give me negative 2? I'll go negative 1 times negative 1 and negative 1 plus negative 1. So this first trinomial factors into x minus 1 times x minus 1. The second numerator, 3x squared plus 3, I can pull out the 3. That's my GCF. Dividing each of these by 3 leaves me with x squared plus 1. So that goes here with my numerator, 3 times x squared plus 1. Then for my denominators, I have the first one, I have a GCF. They both have x in common, so I can pull an x out, leaving me with x squared plus 1. So down here I have x times x squared plus 1. And then in my second fraction, that's a trinomial. What multiplies to give me negative 2 and adds to give me positive 1. That would be positive 2, negative 1. So I'll write it as x plus 2 times x minus 1. Step 2, factored everything that I could. Step 3, I need to state my restrictions. Go to the current denominator and state everything that x cannot be. X cannot equal 0, coming from my first group of parentheses. X cannot be a negative 2, coming from this group. And x cannot be a positive 1. All three of those would make each of these groups equal to 0. Now I skipped the x squared plus 1. Let's take a look at it. If I did x squared plus 1 cannot equal to 0, I subtract the 1 across. So x squared cannot equal negative 1. Get rid of the square, so I'm going to take the square root. X cannot equal the square root of -1. This is the definition of an imaginary number. All I care about are real numbers that X can't be. Real numbers that would make the denominator equal to 0. Because this is imaginary, this group, x squared plus 1, is not a restriction. So I also need to pay attention to the original denominator I had before I took the reciprocal. That's the 3 times x squared plus 1. So again, I have the x squared plus 1, which I already solved below to come up with the imaginary. So my original denominator does not give me any restrictions. All right, my last step is that I can simplify anything possible. I have x minus 1s, x squared plus 1, leaving my final answer, 3 times x minus 1 over x times x plus 2, where x cannot equal -2, 0, and 1. And that is dividing rational expressions. All right, give letter B a try. Go through, do the reciprocal of the second fraction, factor everything you can, state your restrictions, and then simplify. Press pause while you do your work, and then resume play to check the answer. Hopefully that problem went pretty well for you. I'm going to walk you through the steps that I took. I took the second fraction and multiplied by the reciprocal. X plus 3 went up, and x minus 4 came down. I factored. The trinomial went into -4 times 2, -4 plus 2, so it was x minus 4 times x plus 2. The bottom one was a difference of squares, so I got x plus 3 times x minus 3. Putting those together, this was my numerator, denominator, second fraction. I set up my restrictions. The x can't equal -3 came from the first group. X can't equal 3 came from the second. X can't equal 4 came from the third group. And I remembered to go back to the original problem of x plus 3 that was originally a denominator and set it not equal to 0. So the -3 appeared twice. When you write your final answer, you only need to include it once. I did my simplification. The x minus 4 canceled. The x plus 3 canceled. And I have x plus 2 over x minus 3. You cannot cancel the x's. This is a binomial. The x plus 2 is together. And if it helps you to remember, put them in parentheses. Visually, you'll see these are grouped together. Your two binomials are not the same and can't be canceled. And that is it for dividing rational expressions.